Hey. Greetings. Welcome to Unit 8. Good luck these next few days. It's really hard teaching by myself in a room alone, and a lot of what we're going to be doing today is a little bit more hands-on, so hopefully you can see the visuals that I'm going to try to present to you via camera. Now, volume is what we are covering in Unit 8. Volume shows up a lot on stage tests and a lot on ACT tests because it's really easy to throw in a volume question. You just throw in a shape and you ask what the volume is or what the surface area is or whatever. However, in our class, volume is something that I taught when I was teaching 7th grade. It's something that if you know the formula, it's really easy to plug in numbers and you're done. We're to the point that we're moving on just plugging in numbers in a formula. I need to be able to figure out what the formula is and why the formula is what it is. So, today our goal is to come up with the formulas to find the volume of different solids. Now when I say a solid, I mean a three-dimensional figure. To do that, I'm going to start by looking at what different figures look like and how you get from one figure to the next. I did not include the 0 dimension, which is actually a thing. Give me 1 second. So I've got the 0 dimension, the first dimension, the second dimension, the third dimension. We're going to talk very little about these first three and spend most of our time in the 3D world. So if I have something that's 0 dimensional, that means it has really no width and no height. It's one little tiny point. Now, it's kind of tricky talking about infinitely small things because we can't really see anything infinitely small. We do the best we can with just the little dot. So that is something that would be in the 0 dimension. It has no height. It has, now it does. It has no height. It has no width. Now if I were to line up all of these 0 dimensional figures over and over again, what does it create? Seemed like that's straight. I was doing a better job when I was just dotting it. So if I were to line up a bunch of 0 dimension figures, it creates this line segment. Now in the 0 dimension, when you just have that infinitely small point, there's no measurement. Because it's something that's infinitely small. However, once I line a bunch of them up and start to get some sort of a width, I can measure something in the first dimension, and when I measure it, when I measure the length, the exponent is going to be to the first degree because it is one-dimensional. So we would measure it in like inches or meters or yards or miles or centimeters. But if I'm just measuring length, that's what my units would look like. Now, if I were to take my line segment and line them up, now this line segment is infinitely skinny, has no height, it just has the width. But if I were to take my line segments and line them up, which is really hard to do on a whiteboard, but bear with me. Now we're going to have this object that has a height and it has a width. So I can call it a length and a width. When I'm looking at two-dimensional figures, I can calculate the area. The area is the length times the width. It's how much space would fit in this little box. Now, two-dimensional figures calculate their area with the power squared. So if I'm calculating area, it's going to be inches squared, or meters squared, or yards squared, or miles squared, centimeters squared, and so on. That's how I would calculate area. But still, this, if I were to look at it, it is infinitely thin. It just has a length and a width, but there's no height. So this one has no width or no height. This one has nothing at all, so 0 dimension. Now what happens, let me show you this way. So this would be something that's 2-dimensional. Now technically it's 3-dimensional, but because I have it in my hand, but pretend like this is infinitely thin. What happens when I take something that's infinitely thin, but I've got a length and a width, and I start stacking one on top of the other? Eventually, what's going to happen? As I stack more and more, you should start to see a width coming. Or a height, I guess. So can you see that it's getting a little bit thicker? For sake of time, pretend like these are all the same. So if I have all of these planes, because something, you can't even see that very well. I can see it really great on my computer. Let me focus. I guess it's recording the computer. Maybe it will be okay. Let's see, hold on. There we have it. And then, sorry, I'm prepared. Hold on. Freeze this. Okay, so if I have something that is infinitely thin, but I keep stacking them just the way I stacked the other ones, now I have something in the 3rd dimension, where you have a width, pretend like these are all the same, you have a width, you have a length, you have a height. Now before, there was no measurement in the 0 dimension. I could calculate the length if it was 1-dimensional. I could calculate the area if it was 2-dimensional. If it's 3-dimensional, where you have this plane and you keep stacking planes on top so that you get a height, we now have a 3-dimensional solid where I have a length, I have a width, and I have the height. We've already said the magic word. Volume is what you can calculate if something is 3-dimensional. Now the exponent is just like the exponent for the other ones. Since it's 3-dimensional, I'm going to put my units with 3-dimensional units. So inches cubed, meters cubed, yards cubed, miles cubed, and so on. So that's how a 3-dimensional figure is brought about. Now, using the same logic, could we figure out what a 4-dimensional figure would look like? Perhaps that's a different lesson for a different day, but that would be something interesting to explore. At least interesting for me. I would really like to. What a 4D object would look like. Now, note the volume of a figure is the number of units is the number of unit cubes required to fill a solid completely. So thinking of a swimming pool, I have a 1-by-1 unit. If I want to know the cube gallons that can go into a swimming pool, that would be how much 1-by-1-by-1 blocks of water I could put into the swimming pool. In other words, it's the total amount of space that an object can take up. Now the 2 different kinds of solids we'll be talking about are prisms and pyramids. You should already know this. Prisms and pyramids are named by their base shape. So the difference between a prism and a pyramid is, on a prism, the base, and then if you could see it, this top base right here they are parallel with each other. So this square base right here and this square base right here, they are parallel to each other, and so on. Now we name it based on the shape. So this base is a triangle, so I'm going to call it a triangular prism. This base is a square, so I'm going to call it a square prism. This base is a rectangle, so it's a rectangular prism. A pentagonal prism, because that's that base shape. A hexagonal prism, because that's the base shape. Hexagonal would be a 7, octagonal would be the 8. Now a pyramid has a base, so this is the base, but then all of the points or all of the segments come up and they land right in the same point. So that's what a pyramid will look like. I'm calling this a triangular pyramid because the base shape is a triangle. This base shape is a square, so it's called a square pyramid, rectangular pyramid, pentagonal pyramid, hexagonal, octagonal, gonal, I'm not sure, and so on. Today, our focus will be on prisms, and then we will talk about pyramids next time. So, my typo, prism is a solid figure with two parallel bases. A pyramid is a solid figure A pyramid is a solid figure with its side segments intersecting at one point. Now it's kind of tricky for me to know how long to wait for you to write this down and how long to, if I'm going to wait too long or go too fast, whatever. So if at any time you need more time writing something down, just raise your hand and we'll pause the recording. We can't wait forever because we need to do the homework and I've got to finish the lesson in the class period, but if you need a little bit more time and I'm racing through this, just raise your hand and it will be paused for you. All right, moving on. So now I've got to figure, I think that I must have autocorrect because I swear I know how to spell the word prism. It's okay, you can make fun of me. So now we have to figure out the basic formula for the volume of a prism. Let's go back to our idea of this. How would I find the area of this rectangle? Area of a rectangle is length times width. Can you see that? No. Let me get a bigger marker. Hold on. Length times width. Now, as I add depth to my prism, because if I want to find the area of this, it has no depth, right? And as I add depth to my prism, what you'll do is you'll take the area of the base, because in this case I'm dealing with a rectangle because that happens to be the solid that I'm working with. However, if I had a triangle base, we would do the area of a triangle. And if I had a circle base or a rectangle base or a square base or a pentagonal base, we would find out whatever the base area is and we would multiply by the depth that it is increasing, so by the height. Can you see that? Was that worth it? By the height. So if I want to find the volume of a solid, all I have to do is take the area of whatever base I have and multiply it by the height of the solid. So let's do that right here. let's find the basic formula for the volume of a prism. The volume equals the base area, so maybe off to the side, the volume equals the base area times the height of the solid. Now notice, when I was dealing with this rectangle right here, I didn't use h for either of those variables. Sometimes you see the area of a rectangle to be base, I feel like that's a b, whatever, base times height. I didn't call it base times height for two reasons. One, this b could be confused with this b, and another, this h could be confused with this h. So when we are talking about the area of a rectangle or the area of your square or the area of your triangle, we want to use length times width rather than base times height, because both of those are acceptable. Okay, so what we need to do then is remember what the area formula is for all of the different base possibilities. Now, one thing to note is you will not get any formulas on this test, which is why we're spending so much time right now figuring out what the different formulas could be. So for the triangle, let's start with square. For the square prism, each side I'm going to call S because they're the same. Now the rectangle is different, right? On my rectangle, pretend like this is the base. It's probably wise to highlight the bases. On the rectangle, these two sides are not the same, so let's call it length and width. But on the square, all four sides are the same. So how do I find the area of the square? So volume equals the base area, which is the length times width, so S times S, because that's how you do it, right? And then the height of the square would be this. S squared, just to make note, is the area of a square. And this guy right here is the height of a prism. I probably won't mark that for all of them. Okay, now let's look at the triangle. Do you know how to get from a square to a triangle? All you got to do is cut it in half. If I take half of that square, it is now a triangle. So the formula for the area of a triangle is 1/2. Again, this is the base. We're going to call this hold on, let me think about this. This would be, remember I can't call it height because h is going to be something else. Let's call this right here the length. Let's call this the width. So the formula for the area of a triangle is 1/2 length times width times the height of the prism. Again, this right here has to do with the triangle. This right here has to do with the prism. So on your own, take 30 seconds and figure out what the volume of a rectangular prism is. Now really quick, check with the person sitting next to you. Let's see if you got the same thing. Okay, so the volume of this guy has to be the area of the base, which would be length times width. Again, This is the rectangle times the height of the prism. We can put that right here. Now you may be wondering, especially on the rectangle or on the square prism, how you decide which one is the base. And the answer is, it doesn't really matter. This could have been the base. This could have been the base. That could be the base. And the reason it does not matter is because if I have length times width times the height, is that the same thing as the width times the height times the length? All of these are interchangeable. So it doesn't really matter which one your base is. You just pick one and then go from there. So note, you will likely not have, you likely will not have learned what the formula for any shape beyond a square is, because if you remember on the previous page, my base shape could have been a hexagon or it could have been an octagon. Do you know how to find the area of the octagon? I do, but I don't think that in your, I don't even know where that went on the core. We used to do it in geometry, and it's kind of fun. Well, okay, I think it's fun. But I don't think they teach that in the regular core anymore. It might be in the honors core. So if you see something with kind of a weird base like this, it would probably tell you the base equals 24 inches squared. So the area of the base is something, and then it would say like the height is 4, find the volume. But it would have to tell you what that area is because you don't know how to figure that out yet. Does that make sense? Okay. I almost told you to nod, like nod if that made sense to you. Okay, this is what I just said. So the base area will be given to you. So now we're going to talk about cylinders. Cylinders are very similar to a prism. Prisms, I just said prism. Prisms are, ooh, what's the right word? Hold on a second, I'm going to pause real quick. I think the janitor's coming in, hold on. Okay, let's keep going. So cylinders are technically not prisms because in order to be a prism, I can't remember the right word, but all of the sides have to be straight. I can't remember the right word is, but I'll think about it until I do. Technically, a cylinder is not a prism because we have this rounded edge right here. However, the formula for finding the volume of a cylinder is exactly the same as these formulas up here. So, let me get this up a little. If we want to find the formula for the volume of a cylinder, we need the area of the circle, because that's the base, right, times the height of the prism. Now, how do you find the area of a circle? You need this length right here. Area of a circle is pi r squared. That is something you have to memorize. It should have been expected of you years ago, so we have to assume that you know that and keep going. Area of a circle is pi r squared times the height of the prism. That is the volume formula. So now that we have all of our formulas, let's try finding some of the volumes. Do I have a calculator that has batteries? Hold on. The very first thing I want you to do on these, oh yes I do. The very first thing I want you to do on these is name the shape. Before you name the shape, I want you to shade the base of the solid. So this one, I noticed that this is square. So in this case, I guess it kind of matters which one the base is because it's a little bit more specific than the rectangle. So I'm going to call this a square prism. Now there is a special name if all three sides are the same, and that's called the cube. This one's not a cube. By the way, the volume formula for a cube would be length times width times height, which would be s cubed. So I think you may need to know that later. Now, if I wanted to find the volume of this prism, volume equals the area of the base, which is 2 times 2, times the height of the prism, 7. Plug that booger into your calculator or do it in your head, and it is 28 yards cubed. You have to have the units on there. Normally, I'm not super picky about that. However, I do want to make sure you know what dimension we're working in, which would be cubes. Okay, part B. What's the base shape on part B? It's kind of hard to see these sometimes. I'm going to shade in this guy right here. And the reason I want to shade him in is because on the triangle, this is a 90. So this is my length, this is my width, and this 10 right here, that is the hypotenuse, but you don't use the 10 in figuring out the area. This is extra information given to confuse you. This right here is the height of the prism. Can you see that? So, area of a triangle. So my base area is 1/2 times my length times my width, which would be, I guess you can do this 2 different ways, which would be what? 1/2 of 8 is 4, 4 times 6 is 24. Now the formula for finding the volume is the area of the base times the height, right? We figured that out already. So volume equals 24 times 8, which is 192 feet cubed. All right, let's do another one. This one is a cylinder. So if I want to find the base area, in this case it's a circle. Circle is pi r squared. This, when you type it into your calculator, you get some kind of horrendous decimal. So for now, I want to avoid rounding error and just type it as 25 pi. And then we'll plug everything to calculator at the end. Now if I want to find the volume, you have to take the base area and times it by the height, by the way that was my base, times it by the height of the prism, which would be 9. Plug that into the calculator. So you can see me. Oh, maybe you can't because I changed it. Can you see that? So I plug it into my calculator. And I get 78.5 kilometers cubed. Okay, this wasn't very much practice. On your own, will you please try part D? Now part D is a little bit different than the first or than the last cylinder question, because on part D you're not given the radius, you're given the diameter. So in this one, note that R equals 1, so this is the base. So if I want to find the base area, it's pi r squared, which is just pi, 1 pi. To find the volume, I take the base area and times it by the height. So we get 4 pi, which is, now most of your calculators should have a pi button. Mine right here is the second, I don't know if you'll be able to see it. It's second, and then that little up arrow right there, can you kind of see that little pi right here? Right here. Or if you want to type 3.14, your answer will be a little off, but it will be pretty close. So 12.6 kilometers cubed. So why don't you go ahead and pause the recording, take just a few minutes to try some of these examples on your homework, pass out the homework. The first 12 questions have to do with this. So I want you to shade the base, name the figure, which I think I stopped doing. Let's go back up here. This guy is called a triangular prism. Because the base is a triangle. This right here, the base is a circle, so we're going to call it a cylinder. And likewise, this one right here is a cylinder. All right, take maybe 10 minutes, get as many of those first 12 questions as you possibly can. Okay, sometimes it's going to be useful to be able to rearrange the volume formulas for different variables. Sometimes I know the volume of something, I just need to know how tall I can make it. So, for example 2, we're going to rearrange each volume formula for the given area. So solve the cylinder formula for R. The very first thing we need to know is what is the cylinder formula. Volume equals pi r squared h. So you have to, why don't you just watch and then we'll take a second to write this down. You have to get this little r all by itself, which means you have to get rid of the pi, the h, and the 2. Your first step is to look to see how each of these are connected with each other. And they are connected by a multiply. So your first step is to get them to the other side by opposite of multiply, divide. Now you could do it individually or you can do it at the same time. The pi's cancel, the h's cancel, and you've got r squared equals volume over pi h, or pi times h. I'm a little bit nervous that you're not going to be able to see this. Maybe you will, and this is normal. Now, how do you cancel a squared? What's the inverse of squared? Square root. So if I want to cancel that squared, I have to do the opposite, which is the square root. Now normally when you put a square root on, I'm going to have you put a plus or minus. However, is it necessary in this case? If I put a plus or minus, that would indicate that your radius could be negative. Is it possible for the radius of something to be negative? Think about it. Is the radius of this disk negative, or can I actually measure it? So the radius of something is always going to be positive, so I don't need that plus or minus. You only have to worry about the positive. So radius equals the square root of volume over pi h. Now we probably should plug these, put parentheses around those, just so that when you plug it into the calculator you don't make a mistake. And that's what you got to do. Let's try the next one. So solve the square prism formula for S. So remind yourself, volume equals the area of the base. So if it's a square prism, so this is the prism itself, it's S times the height, right? So volume is S squared H. And I want to get this all by itself. So the very first thing you do is see how these two are connected together. You can't take the square root of something until it's all by itself. So you need to cancel the times h. Let's divide both sides by h. And volume over h equals S squared. Now, you can take the square root of both sides. Just like before, you don't have to worry about any sort of negative option, because you're always going to have a positive. So my side length equals the square root of the volume divided by the height. So I want to take just a second, and pause it if you need to. Talk to the person sitting next to you, behind you, around you. Raise your hand if you're lucky to be in my A2 class. Ask Wagner, he's there, put you on the spot, Wagner. If you have any questions, pause it, take just a second, see if you can figure this out. While you're waiting to move on, if you feel really good about it, why don't you solve the triangular prism formula for W? So remember, the volume formula is 1/2 times length times width times height. So see if you can solve this for W. I'll give you 2 minutes to talk to each other and try this next one out. Okay, let's try this next one together. If I want to get W by itself, this one might take just a few more steps because dividing by 1/2, this is connected by a multiply. However, dividing by 1/2 is tricky. If you are dividing by 1/2, you are also multiplying by 2. So I could times both sides by 2, and the 2 and the 1/2 would cancel. So on the right, you would just have length times width times height. And on the left, you would have 2V. Now you're trying to get W by itself, so we need to cancel the length and the height. The lengths cancel, the heights cancel, so W equals 2V over LH. All right, last one. Solve the cylinder formula for H. So again, the volume of a cylinder is pi r squared h. This time I want to get h by itself. So we are going to, all of these are connected by a multiply. We can divide them all out. So on the right, the pi's cancel, the r squareds cancel, and h is alone. H equals volume over pi r squared. Again, use the parentheses if you're plugging it into your calculator. So again, pause the recording. Take maybe 5 minutes this time, depending on how y'all are doing with time, and try those next, I think 4 problems is all there is. Pause the recording, try those next 4. Actually, that's the end of day 1. So, wow, we're done. That makes me feel good. I hope this makes sense. If you want to rewatch this is already on my YouTube channel. I know that this show is better in person, but thanks for watching, and peace out.